everyone, and welcome to this particular video in which we'll be discussing all about NumPy. Now, to know NumPy, we'll need to know Python first. So please check this video on Python so that you can dive in NumPy for data science and data analysis. Now, in Python, there is a huge limitation, and the limitation is that you cannot perform arithmetic operations really well on large number of data sets. Like, there's no provision for having multi-dimensional data. Storing multiple entries in a single variable, you can do it easily using a list or a tuple. But then when you try to add them out, right? When you try to add data of two lists, it won't perform an arithmetic addition. What it is gonna do is, it's gonna do the job of concatenation. And we don't want that, right? So that's why list or a tuple or a dictionary or a set or any of the data structures or data types which are present in core Python are not efficient enough in performing arithmetic operations or performing numerical analysis. So that's why in Python there is an exclusive library which is defined or derived or made for performing numerical operations, and which is called as a NumPy library. NumPy name itself is made up of two words: numerical, Python. So num of numerical and py of Python is taken and joined, and then the library name was derived, that is NumPy. And this does what the names consist of, that it performs all the numerical operations which are to be done for any kind of operations, right? Now let's try to know more about it. Now, within this NumPy, there is an exclusive data structure, what I call it as a hybrid data structure, which is used for all sorts of mathematical operations. And that can be created using the existing data types, that is list and a tuple. You can use these two to create a NumPy n-dimensional array. And this array's uniqueness or a value proposition for numerical operation is that it will help you to perform all sorts of different operations. And the unique characteristics of NumPy n-dimensional array is that it will perform all sorts of multi-dimensional data requirements. Like, if you have a requirement to create a 3D data, you can create within the NumPy array. If you want a 2D data in rows and columns, you can again do that within the NumPy array, right? So you have all sorts of multiple dimensionality characteristics within the data within NumPy. Similarly, the arithmetic operations which we perform, like I just gave you an example, right? I'll also show you that within this notebook. So I'll just start a new notebook over here, and I'll just show you that if we have this list L1, and if this list is having say 10, 20, 30 and 40, that's my list L1, and we have a list L2 which is say 100, 200, 300 and 400. If I try to add these two guys, right? And by add, I mean that I want to add this 10 with 100, this 20 with 200, this 30 with 300, and this 40 with 400, right? I want to add them one on one. I just don't want to merge them. I just don't want to concatenate them and have an array or a list of 10, 20, 30, 40, and 100, 200, 300, 400. We don't want that. We want 110, 120, 130, and 140. So that cannot be performed in a simple Python. You have to apply all sorts of different loops so that one by one you pick 10 and 100 and then add them up. I'll show you that. So if I just do L1 plus L2, it's just going to concatenate and give me. What I'll have to do is I'll have to write L1 square bracket 0, and then I'll have to write L2 square bracket 0. I'll have to pick them up from positions, right? As we have again seen in the previous video, right? Again, if you have not watched my video, which is on Introduction to Python, please do watch that. After that only you will be able to understand all of these things. So if I just run it, now you can see it has 110. because it has exclusively taken this 10 and exclusively taken this 100 and then added them up and given you 110. So you need to do that, right? Now, if you directly do it, you just get this one. So what I can do is I can create a loop which would run say 4 times. So if I write for I in say range of 4, right, for loop, and then what I can do is I can simply write say print or say I can create an empty list L3, and in that L3 what I can do is I can append my L1 square bracket 0 or L1 square bracket of I plus L2 square bracket of I. Now if I zoom in, so can you see this? What is happening over here is I am simply like, when the first time the loop I value will be 0, it will get 0 over here. So with that 0 it will fetch the first value, that is 10, and then with this 0 it will fetch this 100, add them up and append it. Next time 1, so 20 and 200. Next time 30 and 300. Next time 40 and 400. So like that it will take up all different values and then add it up, right? So if I run it and if I show you my L3, can you see you got 110, 220, 330 and 440, right? And you are getting a list. So you have to apply your entire for loop and then do this simple arithmetic operation. Just the operation way of performance is one-on-one, positional, right? Now that's the limitation of your core Python. Now to overcome this, we have a very wonderful library which we just discussed about, that is NumPy. So this limitation is covered, that NumPy is faster in execution, it has n number of different functions for arithmetic operation, and yes, you can have your multiple dimensionality, okay? And the only core thing which you need to remember is that the entire NumPy array is gonna be in a single data type. If the array is in integer, the entire if there is one value, all the values as integer, the entire array is of integers. If there would be one single value which would be float, the entire array is going to get converted into a float value. So you need to remember this, right? If there is one string, the entire array is going to be of type object. So array holds data in the same data type, right? So only one data type is being considered, and priority is being decided what is there. So do remember about these important points, right? Because this would later on lead to data cleaning processes, and the data would not be in the best form, so that you will have to clean it out, right? So that's why in the data science application of this, you have a process called as data cleaning, which is basically done because of this scenario, okay? Not going into that band, let's try to import this library and get working, right? Now, when we say a package or a library in Python, we basically mean that we are trying to perform some kind of structure, or we are trying to leverage some kind of structure which is stored somewhere else. So small snippet of codes are functions which are bundled up together to perform specific task are functions. Similar such functions, right? Similar such functions, we can again bundle them up and keep it in a package, and from that package we can leverage these different functions out, right? So function, collection of such functions within a package, and from that package you can access any of these functions of similar objectives to perform your own action, right? And that is what is the library. So NumPy, all the numerical arithmetic operation related functions could be done, or metrics related operation could be done using NumPy, okay? Similarly, later on, all the data visualization stuff could be done using a matplotlib or a seaborn library, right? Which we'll be seeing in the coming future videos, right? One more thing, I would want you to stop over here and just comment over there in the video that which exactly topic you want to hear in the future videos, right? Right now I've covered like your Python and NumPy, and then in future I'm planning to take Pandas, Matplotlib, Seaborn. If there is something else which you want to learn and know more, you can write that in comments below. I would surely try to make some video on that. Okay, coming back to this, yeah, so we'll have to first load that particular library, and that library would be like, say, import NumPy as NP. Now NumPy is the library name which I'm using this reserve keyword import, and since I am writing as, means I am using an alias name for this library or a package. So NP is an alias name for NumPy. So wherever I wanna make use of NumPy library, I can just write NP short name over there. Now you can give any of the name what you want, but this is the one which is like a standard one and which is being used largely. Okay, run it. Now everything whatever is in NumPy, right, it is accessible using this NP. Okay, so what we can do is, now we can simply write NP dot, and then we can make use of all the different functions which are available over there. So if I write NP dot, and if I hit tab, I'll tell you a big secret, right? If I hit tab, it will give me all the list of functions which are already present over there. So there is a function to clip, there is a function to create a complex, there is a function to copy, there is a function to like perform a data and type operation, get diagonal, perform dot product, right, stacking, everything. So there's a huge list, right? I have not explored everything, no one does, but yeah, there are all sorts of different functions which are already present over there which we can make use of. Okay, so you just need to like write the library name or an alias name, and then just hit dot and then tab, you'll get that entire list. Okay, and then you can start writing like this. So if I write array, you can see I'm getting all the hints, right? And then I can choose this, and then I can do shift tab. You can see you get the doc strings, which is the help, right? You can read about the function in detail and get an idea over that. Like you can hit this plus and you can get to know more about that as well. So this function is used to create an array, and these are the parameters within that function. Okay, now moving ahead, what I'll do is I'll try to create an array with some values in it. So I can just simply write a variable arr, and I can use np.array square bracket, and within that I can write 1 2 3 4, and I can run this, and I can write arr. Now if we try to just show this arr, you can see it gives an output as array 1 2 3 4, right? And if we try to print, say, arr, what you see is you'll get 1 2 3 4. So this looks like a list, but it is not a list. Okay, it's an array. If we check type of this guy, right, arr, you'll get to see that it is a NumPy ND array, that is NumPy n dimensional array. Now I told you that it could be in multiple dimension too. So if we just write, say, arr dot n dim, now this will give you 1, which means that the array is of 1 dimension. Similarly, if you write arr dot shape, now in 1D there is no shape because there is no rows and columns, but in 1D you will get what is the number of elements in that. So there are 4 elements, 1 2 3 and 4. So that's why it's giving me 4. That is means there are 4 elements in that 1D array. Okay, now moving ahead, I hope that it is quite clear until here that I used a list to create an array, arr, and array was a function. So the function which is used to create an array is array, which is in NumPy, and then using ndim, shape and type, we check the following things, right? Now the next is we can convert the existing list or a tuple into an array as well. So if I write a is equals to np.array L1. So I hope you remember this L1 and this L2. So I'm using them. And then if we write b as np.array L2 and I run them. So if I see a and b, can you see that I have 10, 20, 30, 40 and 100, 200, 300 and 400, and now there is a prefix coming as an array, right? So these two are arrays now, not list anymore. List as well exists in L1 and L2. Okay, Now, when I just simply try to add them up, a plus b, and run it, I'll get 110, 220, 330, 440, right? It's very powerful. Like, you can use a huge amount of data as well and get the arithmetic operation done one-on-one. Now, obviously, if the shape is not same, means if the A would have 3 elements and B would have 5 elements, it won't perform because it needs to do one-on-one mapping. It needs to have same shape, right? So that's why you were able to perform this, which was not possible earlier in a list or a tuple. It was concatenating them, right? Or else you had to do it with a for loop. So a larger complex operation, large complexity means higher the time. Here it's faster. So that's why for arithmetic operations, NumPy is the best. Then, like, why only addition? You can perform b minus a, so it would give you difference. You can perform a into b, it would give you product. So all the arithmetic operations, whatever you have, right, they can be performed over here. So you can do addition, subtraction, multiplication, division, modulus, power, floor, everything over here. Okay, now you can try that out and I'll move ahead. So let me try to show you one two-dimensional array. So this is a 1D array, right? I can show you a 2D array as well. For a 2D array, if say we'll have to use some reshaping function, okay? And before that as well, I'll show you one very powerful function which is called as Arange. The spelling is Arange. Don't call it arrange, right? Like I see a lot of my students call it arrange, which is not correct because the spelling is not Arrange. It's not arrange. It's arrange. Array, range. Okay, it's just an extension of the range function from your Python. So if you remember range, it was used to generate continuous data with 3 arguments, 1 argument, 2 argument, or 3 arguments, right? Similarly, that guy can be used over here to generate with 1 argument, 2 argument, or 3 argument to generate a continuous numbers. Okay, so if I write np.arange 5, I'll get an array of 0 to 4. With range, I would have got a list, right? I would have typecasted it. So np.arange, if I would have written 1 or say 5 to 11, I'll get 5, 6, 7, 8, 9, 10. Are you getting my point, everyone? If I write np.arange starting from 2 till 21 at a step of 2. So I'll get 2, 4, 6, 8, 10 till 20, n minus 1. So if I run it, can you see that I've got an array of even numbers starting from 2 till 20, right? So this is how basically Arange is, and you can generate huge chunk of an array. And all of this is 1D. I'll give you a small trick as well to see how the data is 1D. If there is one square bracket over here, right, it's a 1D array. If there is one square bracket, this entire thing is a list, and from a list, if you create an array, it's 1D. Okay, now do you remember this L1, L2 guy? What I'll do is I'll just try to quickly add title over here as 2D array. Okay, so see this. Now this were 2 different lists, and yep. Now what I can do is I can create a combined list or a nested list. So if I write L, you can see this is my first list, this is my second list, and both the lists are within this big list, right? Now what I can do is I can simply say have this L guy converted into an array. So I can write A to D is equals to np.array, and within that I can just pass this L, which is a nested list of same elements. And when I run this, if I see this A to D, can you see you have 10, 20, 30, 40, 100, 200, 300, and 400, right? So you can see this first guy is first row, the second guy is second row, and you are having 4 columns. So basically it's 2 rows, 4 columns, and that's what is a 2D array. You have rows and columns now, right? And if we just check the shape, A to D dot shape, you get 2 comma 4, that is 2 rows, 4 columns. Okay, note this is an array of 2 rows and 4 columns. Okay, similarly you can even write a2d.ndim to check what is the dimension. So if I run it, you will get 2, which means that the data is of 2D array. Okay, the data is having 2 dimension. So that's how you can create a 2D array using multiple list by concatenating them. You could have even directly used this guy over here too. Okay, that was also possible. Secondly, with Arange also you can reshape the existing array. So suppose if I want to create an array of shape, say 3 cross 3, 3 rows, 3 columns, right? And I want it to have 1, 2, 3, 4, 5, 6, 7, 8, 9, right? I could even do that. So if I write np.arange, and if we start from 1 and go till 10, means we got 9 numbers. And to this, if I use reshape, okay, and if I write 3 comma 3, and if we run this, can you see that we have a 3 cross 3? Now when you see 3 cross 3, don't think that it is a 3D array. It's just having 3 rows and 3 columns. So it's still 2D. So if I just store this in say C, right, and if I show you this guy, and if we do n and dim, and if we do shape, you get 2 and you get 3 cross 3. Right? Are you getting this, everyone? I hope that this is being clear to each and every one of you. Right? So that's how you can create an 1D array, 2D array in Python. That's that easy. Okay? Similarly, now we'll try to understand how we can select an entry from an array, how we can slice an array. Okay? So say for example, as well as slicing. Okay, so what I'll do is I'll basically take this C guy, and before that even I could take this A and C. Now A is a 1D array, right? It is a simple 1D array. It's with 10, 20, 30 and 40, right? Now how the indexing was there in list or tuple, sequential and ordered, 0, 1, 2, 3, 4, right? -1, -2, -3, -4. It's same there. It's same here. Okay, as there. Now, if I write a square bracket 0, I'll get 10. If I simply write a square bracket -1, I'll get 40. Right? It's pretty same. And concept of broadcasting or slicing means we are fetching some intermediate values. So if we are writing a square bracket 1 colon 3, right? Now I'm not investing much on the slicing concept because we have seen this already in Python. So again, a caution, if you have not watched the Python video, please do watch it. Okay, it's a good one. You will be able to understand everything in Python. Now, if you write a1 colon 3 and if we run it, we got it starting from 1, that is 20, and we got it ended at 2, that is 30. So starting from 1 till 2. Okay, slicing can be simply done. If you want alternate, you can write colon colon 2. You get the alternate elements, that is 10 and 30. So this guy is step. If you give a negative step, colon colon -1, you can even reverse it, right? You can even reverse your entire array. So that's also possible. Now, moving ahead, if we take a 2D array, right, the C, and now over here the difference within this is that first is row, that is 0, this is 1, this is 2. Similarly, first column is 0, second column is 1, third column is 3, 0, 1, 2. Okay, so this guy would be 0, 0, this guy would be -1, -1, or 2, 2. So 0, 1, 2, 0, 1, 2. So this position would be 2, 2. Okay, I'll show you that. See, if you just write C square bracket 0, you get the first row. Okay, by default it's for rows. If you write C square bracket -1, you'll get the last row. Okay, and if you write C square bracket say colon, you'll get every row. Okay, you'll get the every row because it is starting from 0 and going till the end. Similarly, if you give C square bracket 0 comma colon, right? If you give 0 comma colon, means you'll get 0th row of first column. See this. You get 0, 1, 2, 1, 2, 3 means, see this, you get the 0th row and all the columns. So you are getting 1, 2, 3, correct? Now if you want 1, 4, 7, see this, if you want 1, 4, 7, so you'll write C square bracket, all the rows, give colon in the place of rows, comma, 0th column. So 0th column, you'll get all the rows. So see this, you'll get 1, 4, 7 with this, 1, 4, 7. Now it will eventually give you 1D array. If you want 2D, just give one more square bracket. So if you give C square bracket, all the rows of 0th one, you'll get it vertical. So 1, 4, 7. But now since it's coming vertical, it's not 1D, it's a 2D. So you're having 3 rows and 1 column. Okay. Now you can, if you want to fetch 5, you can write 1 comma 1. So 0, 1, 0, 1, right? So if you give C square bracket 1 comma 1, you'll get 5. So like that you can fetch any rows, any columns, any particular individual value from an array. Okay. Now moving ahead. So basically this gives you an idea about what NumPy is, how a NumPy array can be defined, and how a NumPy array can have the selection techniques, right? Slicing technique. And we also saw some basic function, that is a range function and reshaping function to change an array. And we have also saw what is the 1D array and 2D array. Now within this there are a lot of things, like you can perform arithmetic operations, you can perform relational operation, you can get it to check whether the value is greater than something or not, right? Any of the things. You can do stacking, you can do concatenation, like all the different logical operations could be performed. Okay. And on top of it, there are huge amount of functions like mean, median, mode, standard deviation, correlation, and the list can go on and on and on. Okay. But I'll show you some. So let's increase the size of an array. So say for an example, I take an ARR1 as np.arange starting from 1 going till 25. So I'll write 26 and I'll reshape it to say 5, 5. So there are 25 numbers, right? And then let's look at this ARR1. Now we got an array of shape 5 with starting from 1 and going till 25, right? Now within this, what we can do is we can even get a diagonal. Right? So if I write ARR1 and now I don't know what is the function for diagonal, I can write di, and can you see diagonal, and you can just run it. Okay. So can you see that it is giving me a 1D array of all the diagonal values? That is 1, 7, 13, 19, 25, 1, 7, 13, 19, 25. Yes, we are getting diagonals, right? So that's the beauty. Now, if I write ARR1 dot mean, run it. Can you see I'm getting mean as 13? So it's adding all the values within an array and giving me an average of 13. If I want sum, I can write ARR1 dot sum even, and it will give me 325. So it's adding up all the values, right? I can even write a square bracket 0, so it will fetch only the first row, that is ARR1 square bracket 0, that is 1, 2, 3, 4, 5. And if I want to take sum of this, right, 5 plus 4, 9, 9 plus 1, 10, 10 plus again 2 and 3, 5, 15. So sum would be 15, right? So if I write ARR1 square bracket 0 dot sum, and if I run it, can you see I got 15? You could do it for column wise. Now you just need to join the concepts and work it. Okay, it's that easy. The functions are that easy. Now even there is a method in which you can write np.sum of ARR1, like you can write the name of the library, LEI's name, the function name, and then pass an array. This is how you can perform a sum function on an array. And like sum, I told you there are a lot of functions. So performing different logical, arithmetic, and whatnot can be done using NumPy library of Python. And that makes this library very unique and very useful for all the different processes involving data science, machine learning, artificial intelligence. In AI, exclusively NumPy plays a very vital role to play around images and videos. And in data science, it is clubbed with Pandas library to perform all different kind of operations in the backend. Okay, and with this we come to an end of this video. If you like this one, please do like, share and subscribe. And if you want some more exclusive ones, please do tell me in the comments below so that I can help you out by creating some videos on those topics. Thank you so much everyone.